Today we're going to do lesson 6.3, exponential functions. Now, so far, you have learned linear functions. Can anybody tell me what the graph of a linear function looks like? It's a line. Very good. All right, a line. Listen, your very first lesson in Algebra 2 expects you to know the difference between a linear function, an exponential function, and a quadratic function, okay? We've not got to quadratic yet, but we've done linear. For months now, we've done linear functions, and today we're going to look at exponential functions. So the essential question says, what are some of the characteristics of the graph of an exponential function? Because if you're supposed to be graphing an exponential function and your graph looks like a line, you should know right off the bat you've done something wrong, okay? So look at the definition of an exponential function. It is a non-linear function. Now look at the formula and take your highlighter, and this is the first thing I want you to highlight. I want you to highlight the formula. Y equals a times b to the power of x. Now, how do I know that's multiplication? How should you know that they're multiplying a and b? Because the letters are right next to each other, there's nothing in between them. All right, now look at some things that a and b cannot be. All right, a cannot be equal to 0. In exponential functions, a cannot be equal to 0. B cannot be equal to 1, and b has to be greater than 0. Now, what does that mean? If they're telling us that b has to be greater than 0, what is another thing that b cannot be? Negative numbers. Very good. If that doesn't make sense to you, then I would add a note right there next to b is greater than 0. That is telling us that b cannot be a negative number. Now, as x changes by a constant amount, when you're dealing with exponential functions, we still have to make sure the x's are increasing by a constant amount. But look at what happens with y. Y is being multiplied by a constant factor. So go ahead and underline or highlight the word multiplied, because that is also going to be very, very important here in just a few minutes. Now, example number 1 just wants us to evaluate the function when x equals -2, 0, and 1/2. So here we are. They've given us x values. We're going to plug those x values into a function, and then we're going to be getting y values. How have we organized all this information before? On an x and y chart, all right? So let's go ahead and create ourselves an x and a y chart. And what are the x values that they want us to use? What are the x values they want us to use? -2, 0, and 1/2. Next column is where we will type our function. So y equals 2 times 9 raised to the power of x. And of course, what will be our last column? Our y column. Whatever comes out will go in our y column. Now, we go through and we plug in our values. So y equals 2 times 9 raised to the power of -2. Y equals 2 times 9 raised to the power of 0. And y equals 2 times 9 raised to the 1/2. Now, remember, we're not using calculators to do exponents. And so let me just teach you some shortcuts here, all right? First of all, if we're going to solve this function, we have to think back to please excuse my dear Aunt Sally. Are we supposed to be multiplying first or doing the exponent first? Okay, please is parentheses, excuse is my e, that's my exponents. So I have to do the exponent piece first. So I take 9 to the power of -2. And what did we learn a couple days ago we have to do to get rid of that negative exponent? Put it over 1 and then move it down, right? Because by moving it down, what happens to the 9 to the -2nd? It becomes 9 to the +2nd. And then, of course, we work this out and we get 1 over what? 81, okay? Now, after that, we're supposed to be multiplying by 2. So what is 1 over 81 times 2? We can put a whole number over what? 1. So you're multiplying your numerators, you're multiplying your denominators, and what do you get? 2 over 81. So that's our first y value. Now, let me teach you a shortcut here, all right? And this will work with what we did the other day, all right? But now we're kind of moving forward, so we're going to be seeing negative exponents in problems. So let me teach you a shortcut, all right? If we focus on 9 to the -2nd, all right, what if we did this? What if we went ahead and did the math? What if we went ahead and did 9 squared? What is 9 squared? 81. And what if we recognized, since the exponent was negative, once we get that 81, we're just going to take it and we're going to move it down into the denominator. Okay? If you can see that and understand that, then that would be that would be a shortcut. Instead of having to do all of this work that we just did, you can just think, all right, what is 9 squared? 9 squared is 81, but that was a negative 2, so I've got to move that 81 down into the denominator. Since there was not a fraction to begin with, that's a 1 over 81, and then you could just multiply by 2. If you say, Ms. Johnson, I don't get it. Fine, just do the work. This is the work I taught you the other day. If you get this better, then just go ahead off to the side and do the work. Now, we move to the next one, and this one should be a little bit easier because what is 9 to the power of 0? 0. Is that right? It's 1. Remember, anything raised to the power of 0 is 1. So we have 1 times 2. What is 1 times 2? 2. So the next y value is 2. Now here's one we learned yesterday. All right, so let's do this one off to the side. 9 raised to the power of 1/2. We need to put it into radical form. So if we do that, what is going underneath the radical? 9 to the first power. Remember, the base and the numerator are your power. So 9 to the first power would go back under the radical. And what is your root? 2. Okay? Do I need to put a 2 on the ledge? Is it necessary? No, I can, but remember, when there's no number on the ledge, it's an understood 2. So they are asking us for the square root of 9. What is the square root of 9? 3. So then we go back to the problem, and 3 times 2 equals 6. Another spot where I can teach you a shortcut. When you have a number raised to the power of 1/2, they are asking for the square root of that number. So without having to go over here and change it into radical form, you could just memorize that. You could memorize that a number raised to the power of 1/2 is always asking for the square root of your base. So, for example, if I gave you 4 to the power of 1/2, what are they asking for? The square root of 4. So your answer right here would be 2. Without ever having to go back and put it in radical form, if you would know they're asking for the square root, so the square root of 4 is 2. Okay? So again, that's another shortcut. If you're like, Ms. Johnson, I don't get it. Great. Then just do what we learned yesterday. Take the rational exponent form and change it back into rational form. Now, this is your answer. The chart, we're not graphing this or anything. So this is your final answer. You'll box in the chart. Now for letter B, let's go ahead and create, once again, our chart. What are our x values again? Same x values, -2, 0, and 1/2. And this time our function is y equals 3 to the power of x. And of course our last column will be our y column. So y equals 3 to the power of -2, y equals 3 to the power of 0, and y equals 3 to the power of 1/2. Now, let's use our shortcut right here. Let's go ahead and let's do the math. Let's do 3 squared. What is 3 squared? 9. Now, because the exponent was negative, we know that that 9 cannot stay in the numerator, but it has to move down into the denominator, which makes our final answer what? 9th. So let me say that again. If we go ahead and do the math, 3 squared is 9. I know the exponent was negative, so I have to move the 9 down into the denominator, which leaves only a 1 up in the numerator. So 1/9 is my answer. All right, what about 3 to the power of 0? That's 1. Remember, any number, any variable raised to the power of 0 equals 1. All right, and again, what was our shortcut here? They're asking, if they have 3 raised to the 1/2 power, they're asking for the what? The square root of 3. Now, is 3 a perfect square? No, it's not. So here's all I want you to do. You're just going to put the square root of 3 as your answer. And we're not graphing these, so it's not that weird to have a radical in our answer. Takes us to example number 2. Now again, this should look familiar to you. We have looked at X and Y charts before, and we have decided if our problem was linear or nonlinear. But look at what they're asking today. They want us to tell if the table represents a linear or an exponential function. All right, so as a quick review, I've even put this in your notes for you. Remember, with a linear function, was it linear or nonlinear? Where was our focus? Was our focus on x or was our focus on y? Y, okay? Now, yes, x needs to be following a constant pattern, but we can look at both of these problems quickly and see how are they getting from 0 to 1 to 2 to 3. What are they doing? They're adding 1, all right? And what about b? How'd they get from -4 to 0 to 4 to 8? They're adding 4. Okay, so we can quickly just check and make sure x is increasing by a constant pattern. But the focus for whether it's exponential or linear is on the y. So take your highlighters and highlight the y's, because I need you to remember that's where your focus has to be. Now, with linear functions, remember when we wanted to find a pattern, we found the common difference. So I've added that into your notes. It says subtract the second term from the first term, and then check to see if it works on all the numbers. So let's do that on letter A. So let's check linear. We're going to write down the word linear. How do we subtract the second y value from the first y value? Basically, not how, but what is the second y value? 4, and then we subtract it from 8, which equals what? -4. Now let's circle it, and we've got to test it all the way across. So what is 8 minus 4? What is 4 minus 4? Is that the next number on the chart? So at that point, I'm going to actually erase this piece, and I'm going to cross the -4 out. And now I'm going to write down exponential. Now this is what's new to you. How do we find the number? And I want you to look at exponential. It says you divide the second term from the first term. Really, it should probably say by the first term. And multiply to see if it works all the way across. Now, I need you to, again, highlight the word multiply. And here's why. If you look at the y chart, if you look at 8 to 4 to 2 to 1, what do you naturally see happening? Division. Okay? But exponential is about a multiplication pattern. All right? And that's the mistake I see. I see people dividing by 2 and they can't switch that around and interpret it as a multiplication problem. Okay? So I need you to be careful of that. Exponential is a multiplication pattern. All right? So here's how we do it. We take the second term, which again, what's the second y value? 4. And we divide it by the first y value. What's the first y value? 8. And so that gives me what? Careful. That gives me 1/2. So I take 1/2 and I multiply it all the way across and I see if it works. What is 8 times 1/2? 4. Because what's half of 8? 4. What's 4 times 1/2? 2. What's 2 times 1/2? 1. So does the pattern work all the way across? So this is an exponential function, and I will just have you box in the word exponential. You've already written linear and exponential down, so box in exponential. And listen, it says explain. If you show me that work, that's your explanation as far as I'm concerned. That shows me that you understand there's a pattern of multiplying by 1/2. If you choose not to show me work, then I'm looking for a sentence explaining why you picked exponential. So if I were you, I would just show me the work. Now, some of you are just naturally going to notice right off the bat that this is not a linear function. So I'm okay if you don't show me linear and exponential, okay? But for the sake of our notes, I wanted both in there so you could see what we did, all right? But obviously, if I look at that, I think division. So if I'm thinking division, I'm going to check exponential. I know it's not linear because I know they're not adding or subtracting the same number all the way across. All right, now look at letter B, though. If you look at y, where does your mind naturally go? What do you think they're doing to the y values? 1 to 0 to -1 to -2. Subtracting, okay? So let's just try linear. Let's go straight to linear, okay? So for linear, how do we find the number that we're using? Okay, we take the second y value, which is 0, minus the first y value, which is 1, and what does that give us? -1. So So now we test it. What is 1 minus 1? What is 0 minus 1? And what's negative 1 minus 1? So does the pattern work all the way across? Yes, so we box in linear and we never even have to worry about checking exponential. Because if it's linear, it's clearly not exponential. Now in example number 3, they want us to graph the function and describe the domain of the range. So go ahead and grab your phones, open up to Desmos. Make sure only Desmos is open. And for those of you that don't have phones with you today, I am going to put Desmos up on the screen so you can follow along. I also need to teach you guys how to put a exponent into Desmos because we have not done that before. You notice the problem that I gave you has f of x. What letter are we able to replace f of x with in Desmos? Y. All right, so y equals, you have negative 2. Now notice the 4's in parentheses. This is how we're letting Desmos know that it's multiplication. And then you need to be able to insert the exponent. So if you go down here to the keyboard button, you see a squared and then you see a to the power of b. Well, a squared is going to naturally square stuff. So if you're not trying to raise your base to the power of 2, you don't want to hit the a squared button. You actually want to hit a to the power of b. This is going to allow you to plug in any exponent that you want. And what exponent do we need to plug in for letter A? X. Okay? Now notice, do you see how this is not a line? So if you ever are looking at a linear function instead of a curved line, and if you're looking at a line, you know you've done something wrong. All right, now I also want you to make sure you zoom in, and I'm going to change up a little bit for you, and I would make a note of this if I were you. I'm only going to require 2 points when we're doing exponential functions. One of them needs to be the y-intercept. So if you're looking at this graph, what is the y-intercept? All right, I heard 0, negative 2. So let's type it in and let's label it, and there it is. Now, we need one more point, and this is what I would advise against. I would advise against going up on the curve, because as you look up on the curve, you can see that there is no obvious exact point. Also, what I need you to understand is this graph runs along the x-axis. I know it looks like it almost is laying on top of it, but if you were to zoom in really, really close, this graph runs along the x-axis. So it's not a good idea to pick a point from up there because then you're putting the line on the x-axis. So all that to say, I would go down from this point and let's find the next exact point. Where's the next exact point that you see on this graph? I heard 1, negative 8. So let's type it in and let's see if it does come up on the graph. All right, and it does. So go plot your points. Remember to label them. We always label our points. And then you're just going to have to do your very best because you can't really use a ruler here because once this line comes through 1, negative 8 and comes up here to 0, negative 2, it begins to curve. Again, just make very sure that you're having the graph run along the x-axis. Now, what do you think needs to go on both ends of your graph? An arrow, all right? So that means when we get to the part where they're asking us to figure out the domain and the range, if we have an arrow sending the graph off to the left and we have an arrow sending the graph down and off to the right, what do you think the domain of this graph is going to be? All real numbers, because there's nothing that x cannot be here. So all real numbers. Now let's talk about the range. You know the range is always that one that we have to actually stop and think about. What variable goes with range? Y. All right, and this is where we got to be really careful. If we run our finger along that line, okay, the line up there where it's running along the x-axis, if you run your finger along that line and you come all the way over here to the y axis, what is the highest y value that that graph goes to? Okay, and I'm talking about running your finger right here along the graph until you get over here. What is the y value, the highest y value that you see for this graph? 0, right? That graph does not go above 0 on the y-axis. So that means my number in my range is 0. Now, are all my y values greater than 0? Or are they all less than 0? Less than 0. So there is your domain and your range. Once you've cleared out letter A, you can plug in letter B. Again, we're doing y instead of f of x. What is our function this time that we're plugging in? All right, 2 times, And remember, for the fraction, you do 1 and divided by, and that will give you your fraction bar. All right? And again, we want to hit the a to the power of b button because that will allow us. Now be careful. Do you see what mine's doing? I'm not outside the parenthesis yet. Okay? I need to be outside the parenthesis, so I need to close it. All right? And then I need to hit the a to b button. All right? Be very careful. This thing is very finicky, so if you punch things in the wrong spot, it will affect your graph. So we've hit the a to b button, and this again is raised to the power of x. All right, so I move my graph around. Again, I'm zoomed in so that I'm counting by ones, and I need 2 points. What is the first and most obvious point that I want? 0, 2. I want the y-intercept. So 0, 2. Don't forget to plot and label it. And again, let's not pick a point that runs along the x-axis because we run the risk of putting the line on the x-axis when it really runs along it. Okay, so let's go up from the point. What is the next exact point that you see in Desmos? All right, I hear -1/8. So if we test it, it absolutely is there. So go ahead and plot that point, label that point, and then again, be very careful because you want to make sure that your line is actually curving and then running along the x-axis. All right, put your what on the ends? Arrows, and then let's domain and range. All right, again, what is the domain of this graph? Good. If I have my arrows on both ends of my graph, and I probably shouldn't put it there, but if I have my arrows on both ends of the graph, then that means my x's go off to the left forever, they go off to the right forever, so that is all real numbers. All right, let's talk about the range. What variable is in the range? Y. Now again, if I follow the curve, I am running and I run all the way over here to the y-axis. What is the lowest y value that we see? 0. So once again, my number is going to be 0. And this time, are all my y values greater than 0 or are they less than 0? They are greater than 0. So my range is y is greater than 0. Again, no or equal to, because it never actually goes through the 0 on the y-axis. And that is lesson 6.3.